Friend, this is Shomik Vishwas and you are attending my class of that circuit theory. Today we are attending the 5th class of that two-port network, and our today's topic is the interconnection of two-port or many two-port networks. So many more type of combinations are such there. So today's topic is interconnection of two or more two-port network. So it is also easy part. How to do this? Number one, different type of such connections are available. So number one is called series connection. In the series connection, what you have to do, suppose this is one two-port, this is A, this is another two-port, this is B. Now they are having, in this way they are having their paths. Now if it is series connected, so that is one, this two is connected with this, and these two are connected in this way. So if this is V1A, that is V2A. So if this is V1B, that is V2B. Okay, so what is the process you have to follow? So the first case, you know that V1A equals to Z11A I1 A plus Z12 A I2 A. Again V1B equals to Z11B I1B plus Z12B I2B. So the first equation. The second equation is V2A equals to Z21 I1. Here it is Z21A I1A plus Z22B I2B, and V2B equals to Z21B I1B plus Z22B it should be A, all this, and it should be B, I2B. Now as you can see that all of them are the series combinations, the same current is flowing. So therefore V1A, V1B, if you are adding them up, so obviously this I1A and I1B is same because the same current is flowing, so they can be additives. Therefore that V1A plus V1B equals to, that is Z11 Z11B, so it is Z11A plus Z11B into, as a whole, it is I1 plus, in the same way I2A and I2B is same, so Z12A plus Z12B equals to into I2, so therefore it is equals to V1. So V1 equals to Z11 so summation of a to b I1 plus summation a to b z1 to I2, and v2 equals to the summation of a to b z21 I1 plus summation of a to b z22 I2. So it is z22a and z22b. It is z21a plus z21b. In this way you have to take the summation. So that is the corresponding parameters. Now the second part we can have, that is number 2, that is parallel combination. So in that parallel combination, what you have to do, that two network like this, number 1 and number 2, and that is their ports, because they are the two ports network. So the first one is joined with first one, the second one is joined with second one. Here the first one is joined with the first one, and the second one correspondingly to join the second one. Okay, now here that node voltage is common. Okay, so if it is VA, then it is VB. So it is A, it is B. So what type of network, what type of two-port network we have to use right here? Here you can see that the current is dividing itself. Say if it is IA current, it is just dividing itself in this two section. Okay, so it is IA dashed, it is IA double dashed. Now if this current is IB, so IB is also taking two part. One is IB dashed, another is here IB double dashed. Okay, so what type of parameter we should use here? There must be one Y parameter. Why? Because in that Y parameter we can write that VA equals to Y11 A I. So it is VA Y11 A into I of that A dashed plus Y12 A to I B dashed. Okay, now in the other case, that is VA, we did it. So if it is a VB, so what is VB? That is Y21A, that is it is I dashed A, and what is VB in the sense that is Y21A plus Y22A, and the same thing will be resting IA dashed, IB dashed. Now if you are taking the second case, so it will be same, that here again Y11A, instead of this you should write Y11B, and another is Y12B. In the next case it is Y21B, Y22B. Okay, so as you know that combination of these two means this as a whole I1A and I1B will give the entire I1. So what is I1A? That is I1B. So actually This is what I had to write. This particular one is misleading. Say, I'm very sorry for this. Actually, you should use that y parameter. So what is the y matrix? It is started with I1 and I2. So I1A or IA, I wrote it here, IA, the first current, the second current is IA dashed, the second port current is IB and IB dashed. So it is our I1, it is our I2. So IA dashed into Y11A plus I2. So it is IB dashed Y12 Y12A. Again it is, this is for VA. Again that is V1 instead of I. 4. I am extremely sorry. This is not that. This is not. This is not that. Actually, if you are writing that I parameter, it should be in terms of I. So it should be IA dashed equals to Y11A and VA plus Y12 plus Y12A VB, and that is IB dashed equals to Y21A VA plus Y22 this is 21B and this is 22B VB. Okay, that is IA, that is IB dashed. So in terms of A network we can write this equation. Again that is I1A double dashed, IA double dashed equals to Y11B VA plus Y12B VB, and IB double dashed equals to Y21 Y21, that is B network, so 21B VA plus Y22B VB. So here all are A, it should be A and it should be A. So it is Y11A plus Y12A VB. This is Y21A VA, Y22A VA. So these two currents are additive. So that is the final current IA equals to IA dashed plus IA double dashed. So IA dashed means this, IA double dashed means this. So we are taking VA common, so it should be Y11A plus Y11B into VA plus Y21A plus Y21B into VB. So this is the output. So what is the final output of this network? It is a summation of Y11A to B, again summation of Y12A to B, again the summation of Y21, summation of Y22A to B. So this is a case of parallel combination you have to find out. Now the next one is number 3. This is called the cascade connection. So in the cascade connection, actually the output is connected to one input of the next network. So it is the first one, that is the second one. So this is the first one, that is the second one. So this is joined with this one. So this is network A, this is network B. So we have to use, in such case you can see that V2x equals to V1x I2x equals to I1x. So it is a function of V2 and I2 and V1 and I1. So please use that ABCD parameter for this. So for A, what is that is VA. Here we can write that is 1, it is 2, so it is V of 1A, V1A into I1A, that is equals to ABCD V2A minus I2A. So what is actually that I2 is flowing in this way, so I1 is flowing in the reverse way, so I2 equals to minus I1, we have to put it. So finally for this circuit, what is output coming as V1A equals to A V2A minus B I2A. What is I1A equals to C V2A minus D I2A. That is the case of this. Now in the second hand side it will be this. Again we can write that V1B equals to A V2B minus B I2B. So I1B equals to C V2B minus D I2B. Now here one relation, it can be easily interpreted that the relation is what, that they are multiplicative in nature. Why? Because see V1B and I1B, there is I2, there it is V2, so that I2 V2, this V2 and I2, it will be connected as V1 I1 on that particular network. So it is ABCD1, we better write it as A1 B1 C1 D1. So as we know that V2A minus I2A, this is equals to V1B I1B. So are they equal to each other? So actually if you are starting calculating from that side, so V1A and I1A, this particular part is equals to ABCD, and this part is equals to this, so it can be again given as, so it is, so for in B part actually we are considering this A1 B1 C1 D1, so we should not take it for the first part, keep it just as usual. So it should be A1 B1 C1 D1 of that V2B minus I2B. So this particular part is the all total. So whenever the two networks are in the cascaded form, they are always multiplicative. So besides that, one more things are there. This is called number 4, that is called that series parallel, and the fifth is parallel series. So in that series parallel and the parallel series combination, what happens is, so suppose two network if given in this way, number 1 and number 2, so the input is in the form of series, okay, but the output is not like this. So if the lines are there, so the first one is connected, second one is connected, and you have to find out the parameters. Say it is A, it is B. So how to do this? So if you are using, if it is VA, if it is VB, so the input current is same. So if I am using H parameters for that particular circuit, so I should write in this way that V1 I2, that is in the form of H11, H12, H21, H22, in the form of I1 V2. So this form of I1 and V2. So finally this circuit is evaluated, I1 and V2. So here please see this, if I write this for V1A, so here it is I2, V1A, here the current is I1 is same for the second one. So the second one we should, this is V1A, I2A, that is I1A, V2A. In the second case we should write that V, this is 1, so it is V1B, I2B equals to, here it is all A, here we should write that H11A, these all are A, and here it is B, H11, H2B, H21B and H22B, and the rest is I1B and V2B. Hope you cannot see this last part, that is I1B and V2B in this way. So here if you are seeing this, so here that I2A and I2B. So what is I2A? So the current for A, that is I2A, and what is I2B? So it is I2B. So I2A and I2B, they are basically coming from a single source I2, and that V1 and V2, that is V1A and V1B, are commutative, it means they are additives in nature. So what should I write for this? If you are taking this V1 and V2, so here that is V2A, V2A is common for this, so H11B, and here this second term is I1A, I1A is common for this, so I1A equals to I1B. We should write that I1A equals to I1B and V2A equals to V2B, because they are the parallel combination. So therefore we can write that if you are adding them up, so V1 equals to V1A plus V1B, that is equals to H11A plus H11B, and that is of I1 and plus H, that is H12A plus H12B, that V2. We have to write this is as V2. You cannot follow perhaps, this is V2. As you can say, this is V2, H12A, H12B, that is V2, and that is 1. So finally the hybrid parameters for the series parallel network as H11A plus H11B is the new H11. Okay. Okay, so in this way you have to add all these type of things. Now the last one is also listed. This is called the parallel series. So parallel series, this combination is just the reverse of that particular type of network. So what is the intercommunication connection? That here one network, here another network. So we have to use them in this way, that the first connection, this is the second connection, and this is the third connection. So this is from this region, that is parallel, and from this region it is series. So we have to use the G parameters for this, and finally we can write that G equivalent equals to summation of G A to B as a whole. So G11, G12, in this way we have to find out H11 is G11A plus G11B equals to G equivalent, or G11 equivalent. In this way you have to find out G11, G12, and so on. So these are the all short of examples how to convert that series parallel to series. And if you are using that in a series parallel series combination, this is your final result. So you can easily convert this H parameter to the Z parameter or Y parameters, and you can easily find out what are the series parallel combination for Z network, what is the parallel series combination for Y network, because you have to convert that final stage. Otherwise, whatever the question, it can be remain same. So that's all for the today's lecture. So in future many more classes I will add in my lecture series to give you more numerical example on the two-port network. But two-port network is the easiest thing. Always keep in mind that you have to find out the value as per your preference, any type of network, then just convert it to the first one. What type of question being asked? If it is asked that the Z parameter, you have to find out. You are saying that without using the Z parameter, if you can easily solve it by using Y parameter. So please solve it by using Y parameters. After that, convert Y to Z. Your answer is done. So don't try to recapitulate, don't try to swallow all this value. Please try to find out what is the corresponding value, Y to Z, Z to Y. So please do a lot of practice in this way and find out the final answer. Thank you very much. See you in the early class. The next class, my subject will be that the nature of the coupling. So what is a coupled circuit and what is the nature of it, how the coupling has made, what is the dot convention, etc. It will be the topic on my last lecture. Thank you very much, and the two-port has ended for this.